Okay, let's take a look at a 2 proportion Z interval and a 2 sample T interval. So we're going to be making confidence intervals to estimate the differences. In one case, the proportions, and in one case, the mean scores between two groups. So in this case, we have first generation college students and continuing generation students, right? Comparing those two groups. And so we have a percentage. We have a p-hat for the two groups, 16% and 28%. So you can see that 28% of first generation undergraduates are 30 or above compared to 16. And so what we want to do is build a confidence interval to estimate how much higher that proportion is. And so we have our 5 steps that we complete, and you can refer back to old notes about the 5 steps to construct a confidence interval. The first is to identify the parameter we're trying to estimate, which is the difference in proportion, right? We're really looking at the proportion of first gen minus the proportion of continuing generation students. And we're only given sample size here, and so when we run our test, and we'll show you how to do it using StatCrunch, that we're going to need the number of successes divided by the sample size, which is x over n, but we don't have x. We're going to have to calculate that doing 21,360 times 28%, and then 67,640 times 60%, and that will give us the numbers that we need. Now, let's continue on again. Step 2 is name the procedure, a 2 proportion Z interval. It's named here. Since it's not stated, we're going to use a 95% confidence interval. And then we go ahead and check the requirements, independent, random, and large enough. We don't know if the sample was random, so it's a question mark for us. And depending upon what our population is, these numbers we're going to assume are less than 5% of the population of students, right? College students who go to college. So again, we have some assumptions here. Of course, if we were really conducting analysis, we'd have to do some further investigation. Like in the real world, right? We're doing these as practice problems. And it's large enough. Our samples are greater than or equal to 10, right? When you do the NP, NQ, and then NP, NQ for the 2 different groups here. And then you see we get an answer of 0.113.127. We're going to use StatCrunch to do that. So I'm going to set that up. So we go to StatCrunch. And in this case, we're going to run proportion stats to sample with summary. And so notice in this case here, if you notice, we have to fill in successes and observations for the 2 groups. So let's go ahead and do that. I'm going to put those in. So once we went to sample proportion summary, I've entered in, again, I had to take the p-hat, which was 28% of your observations, and you get that value, and then 16% of the sample size, and it gives you this one. And then we're running a confidence interval 95, and that's it. Notice it's P1 minus P2, the proportion of first gen minus the proportion of continuing generation students, and then just hit compute. That would be it, and you can see we end up with those 2 values there. And that is where I got those numbers, and then we would then state we are 95% confident, right, that the proportion of first gen students 30 or more is higher than the continuing generation students by more than 11.3 to 12.7%. The actual value is somewhere between that. We don't know what it is, right, but we're confident to that level there. So that's our confidence interval for proportions. We're going to do something similar for finding the differences, estimating the differences between 2 groups who take tests. One who does it online, proctored, and one who does it, online, like in person, proctored. Someone's watching over you, versus an online version, which we call non-proctored, and you have the summary statistics there. And so that's the type of data we would be now entering into StatCrunch. But before we do that, we have, again, what is the step 1? We want to estimate, right? We're estimating the mean difference, mean 1 minus mean 2 from the 2 groups. Secondly, again, what method we're going to use. You see that there. 2 sample t-interval, and then we're checking the conditions, right? What are the conditions there? So that's what we're checking. And you'll see less than 5% of the population, students, random, we're unsure. And again, remember, just because we don't meet the requirements doesn't mean we can't do the test, right? We're still going to proceed forward, and it's large enough. And then we go ahead and conduct the test. We're finding the difference, right? These are samples, and we're trying to see if what is the difference for the populations between those two groups. And we're estimating between negative 14.29 and 6.35. It's a little confusing. Think I have a negative and a positive. What does that mean? We are 95% confident, right, that the interval from here to here captures the true difference between the scores of the two groups. So when I subtract the two groups, the difference is going to be somewhere between negative 14 and positive 6, which means, right, that either group potentially could have a higher value. You remember, when you subtract two values, if one is negative, the answer is negative, the first one is smaller. If the answer is positive, the first one is bigger, right? And that's what this notation is here. Let's show you on StatCrunch to run that real quick. So instead of, so let's go ahead, get to StatCrunch. There we go. We would go to tstat 2 sample with summary, and then we go ahead and put in those values, right? We have the values for the first group. You have 70.29, the standard deviation. Remember, these are samples, right? 22.09. Sample size is 30 for the first group, and then for the second group, you have 74 point. So the sample data kind of looks like that it could be greater, that the second group's greater, but again, it's just a sample with slightly different standard deviation. So it doesn't mean that that's true for the population, right? And we have a confidence interval. We're going to use a 95% confidence interval. And we do it, and then that's where you got your answers there, the lower limit and upper limit. So for 2 sample, we're going to be using technology to do that. And then our final conclusion here, right, with that is that, right, we have a conclusion. Since the confidence interval, we'll use that language, contains, right, contains 0, we say there is no difference between the groups, because 0 is a value that could be, right, the value. And if it's 0, that means there's no difference. It contains 0, this confidence interval. So that's it for those 2 examples.